Hello, my name is Daniel Huckaby, and I'm the Solutions Architect from Charleston, South Carolina. Today, I'm going to talk to you about how to repair an ftServer in the event of a CRU or hard drive failure. First, it starts with a fully redundant hardware design. The ftServer is composed of dual customer replacement units, or CRUs, that each contain its own processors, memory, storage, I/O, and power. Because these components are fully contained in each CRU, customers may remove or replace a CRU without specialized tools and while the ftServer continues operating. The redundant components leverage multi-path I/O to prevent data corruption or data loss. Hardened device drivers enable the removal or replacement of a new CRU and allow the platform to continue operation when the isolated CRU is removed and to synchronize the replacement CRU once it's restored. They also allow the ftServer to continue operation and to automatically self-heal in the event of a firmware lockup, a driver-related error condition, or a surprise removal or insertion of a storage or I/O hardware component. For applications, it appears that the ftServer has a single system image, making it simple to operate and maintain. This also allows single licensing as if a single system for both operating systems and applications. Your applications run without modification or failover scripts. Displayed on the monitor is a PlantPAX HMI application running on the Stratus server. Notice this application will continue to run normally without interruption when I simulate a CRU failure by pulling the power cable out of the bottom CRU. The ftServer's lockstep processing synchronizes operations between the Intel processors in each CRU so that each CPU processes the same instruction at the same time down to the same clock cycle. We call this duplex mode. All data is protected, even data in flight, and there is no pause in processing. In the event that one component in a CRU fails, that CRU is isolated and the remaining CRU continues to function normally without a pause in operation. Because the ftServer is designed using lockstep processing, there is no failover from one side to the other. The other half is already processing every transaction, so the system continues to run without any production outage. So I'm going to remove the faceplate. And so notice the blinking green light on the slot 0 hard drive on both CRUs. This indicates the system's operating normally in duplex mode. So I'll begin the simulated CRU failure by pulling the power cable and the network cable out of the bottom CRU. So as you can see here, the power and the network cable has been disconnected from the bottom CRU. And the bottom CRU has no indication lights that it's in operation. And the top CRU is the safe to pull blinking light is saying it's running in simplex mode. So now we have a bottom CRU failure and the top CRU is still in operation and our PlantPAX image is still running without any pause. I will now remove the bottom CRU completely by first removing the screws securing the locking latches in place. Notice this requires no special tools. Now taking the screws out, pulling the locking levers, and removing the entire bottom CRU. Now that the bottom CRU is removed, notice that our application is still operating normally with no interruptions, and the amber blinking lights on the top CRU indicate a simplex status since their partners have been removed. I'll now simulate a new CRU being installed. The Stratus support agreement allows for an individual hard drive or an entire CRU to be sent to the customer in the event of a drive or hardware component failure. Watch how easily a new CRU is installed. Now that the bottom CRU has been reinstalled, the network cable reconnected, and the power cable reconnected, the bottom CRU will begin synchronizing with the top CRU. The more data that is stored on the hard drives, the longer the synchronization will take. The drives indicate they are synchronizing by the amber and green flashes on the source drives. We can see that the drives have now resynchronized by the green blinking lights on each CRU, as we saw before the simulated CRU failure. And you can notice as well, safe to pull. So either one of these CRUs can be pulled safely while the operation continues to run. So now we'll simulate that Stratus support has sent us a new hard drive. I will now install the new hard drive and allow time for it to resynchronize with its partner. Now that the hard drive is installed, the resynchronization process is beginning. The synchronization is complete, indicated by the LED lights on the hard drive, indicating they are now running in duplex mode, and our safe to pull lights being solid on both the top and bottom crucibles. Thank you for watching this tech support video on server component failures. For more videos like this, please visit and subscribe to the McNaughton-McKay YouTube channel.